Assalamualaikum, my name is MOHAMAD SHAFIEY and I'm from Group 1. Today I will be talking or present to you about memory management. First of all, we're going to the introduction. So, what is memory management? Memory management is the process of managing the available memory of a computer system to ensure that it is used to its full potential. Effective memory management is important. And why? The reason is because effective memory management is used to the efficient operation of a computer system as it can help to reduce the risk of errors and improve performance. Static memory allocation. In this approach, memory is allocated at compile time and remains fixed throughout the execution of the program. This is simple to implement, but it can be inflexible as it does not allow for the allocation of additional memory at runtime. Automatic memory management. In this approach, memory is automatically allocated and deallocated as needed, without the need for the programmer to explicitly manage it. This can be implemented using techniques such as garbage collection, which reclaims memory that is no longer being used by the program. Next, dynamic memory allocation. In this approach, memory can be allocated and deallocated at runtime using functions such as malloc and free in C or new and delete in C++. This allows for more flexibility in the use of the memory, but also requires the programmer to be more careful in managing memory to avoid errors such as memory leaks. Next, we go into the structure, design, and architecture. When a process starts to execute, it is placed in the process queue and it is in the new state. As resources become available, then the process is placed in the ready queue. If you want to understand more, you can look up to the figure down there. So, one of the following 5 stages of the process. First of all, we have new. Next, we have ready, running, waiting, and exit. For new, a program is admitted to execute. The operating system will be initialize the process by moving it to the ready state. So in the ready state, the process is ready to execute and is waiting the access to the CPU. For running, the process is being executed by the CPU. At any given time, only one process is in running state. Next, we have waiting. In the waiting state, the process is suspended from execution, waiting for some system resources, such as input and output. And lastly, we have in exit state, the process has terminated and will be destroyed by the operating system.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Irfan bin NAZLI. My metric number is 073140. I will present about the partition of memory for uniprogram and multiprogram. If you can see, there are two diagrams that show how operating system run in the memory uniprogram and memory multiprogram. In the uniprogramming system, only one program can run at the same time in the operating system. For example, the old computer and the old phone. For the multi-programming, memory program, the operating system can run many programs at the same time. So the processor that use must multi-core processor so it can run smoothly. Okay, next is the swiping. Swiping is the moving data between the secondary memory such as hard disk and the physical memory RAM in the computer. There are a lot of benefit to the swiping. One of the benefit is the give some space to the RAM so that RAM in the computer will run smoothly. There are two types to do the swiping. First is the swipe-in. Swipe-in process is the get the data from the storage secondary storage. So we move the data from the secondary storage to the RAM in the computer. Okay, second type is the swipe up. So up is a process out of the main memory and place in the secondary memory. So we move data from the main memory RAM to the second memory such as a hard disk or CD. So that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is IKHMAL ANUAR, matrix number 072Z713. Today I'm going to talk about partitioning. What is memory partitioning? Memory partitioning is the system by which the memory of a computer system is divided into sections for use by the resident programs. These memory divisions are known as partitions. There are different ways in which memory can be partitioned: fixed, variable, and dynamic partitioning. For fixed partitioning, let us think about the jewelry box that store rings. Different pieces of jewelry represent different computer processes. Say you have a jewelry box that displays rings. The box has been partitioned into equal parts. Fixed partitioning is therefore defined as the system of dividing memory into non-overlapping sites that are fixed, unmovable, and static. A process may be loaded into a partition of equal or greater size, and it's confined to its allocated partition. Into a partition of equal or greater size, and it's confined to its allocated partition. For variable partitioning is an alternate solution to address this problem is variable partitioning. In the case of the jewelry box I just mentioned, we anticipate that we possess the different jewelry items with different sizes, so we divide the area of our jewelry box into partition of different sizes. This way, smaller items of jewelry, which is small processes, are assigned small partitions, while the bigger partitions are saved for the bigger items and larger processes. Other than that, I will talk about partitions fragmented, which is we have two partitions fragmented, which is internal and external partition. Which is internal partitions is internal fragmentation happens when the memory is split into mounted size blocks, and external partitions is external fragmentation happen when there's a sufficient quantity of area within the memory to satisfy the memory request of a method. So that is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FAKHRI bin YUSOF, and my metric number is 073876. Today I would like to talk about type of cache memory and memory management strategies. First of all, type of cache memory was divided into two. First is primary memory, which is primary memory is the memory that directly accessible to the processor, and second is secondary memory, which is secondary memory is the memory that is not directly accessible to the processor and must be accessed through an input or output device.
Okay, Assalamualaikum and good evening. My name is MOHAMAD KHAIRULAMIRIN bin SHAIFUL KAMARULLAH. My metric number is BTCL 22072040. Okay, today I will present to you about memory management strategies. There are several strategies used for memory management, including virtual memory, segmentation, and paging. Virtual memory is a technique that allows a computer to use a larger amount of memory than is physically available. while segmentation and paging are techniques that divide memory into smaller units and manage them more efficiently. Okay, next I will present to you about memory allocation. Memory allocation is the process of assigning memory to different programs or process. Memory allocation strategies can be either static or dynamic. Static allocation assigns memory to a program or process before it runs, while dynamic allocation assigns memory to a program or process while it's run. So the differentiation about static allocation and dynamic allocation is static allocation it process before it runs, and while dynamic allocation is processed while it is running. That's the differentiation of static allocation and dynamic allocation. So that's all from me. Thank you.
Assalamualaikum. My name is Muhammad Hafiz Aiman bin Muhammad FATHI. My matric number is 073861. I will present about memory protection. Memory protection is a way to control memory access right on a computer, and it is a part of most modern instruction set architectures and operating systems. The main purpose of memory protection is to prevent a process from accessing memory that has not been allocated to it. Memory protection is also a technique used to prevent one program or process from accessing or modifying the memory of another program or process. It is implemented through the use of memory access right, which determine which programs and processes can access which areas of memory. Next, advantage of memory management. Memory management is management systems in an operating system whose function is to manage the data in a systematic manner. Memory management can improve performance. The user can get or put his data to a desired location. Furthermore, memory management can reduce risk of errors. Processing ability of data increase because of RAM management becomes better. Last one is increased reliability. Data becomes more secure and time consumption in loading is reduced. Thank you.
Hi, my name is Faris Hakim bin Mohamad ASMADI. My matric number is 073691, and I am going to present about disadvantage of memory management. There are three disadvantages, which is the first one is increased complexity, the second one is increase the risk of error, and the third one is overhead. So I will proceed with the conclusion. In the conclusion, memory management is a critical component of any computer system and is essential for ensuring that memory is used efficiently and effectively. Memory management also is the process of controlling and coordinating a computer main memory. It ensures that blocks of memory space are properly managed and allocated so that the operating system OS or the other running processes have the memory they need to carry out their operation. So I think this presentation has covered the basic of memory management, the different strategies used, and how memory management can be implemented in a system. So I think that's all for today. Thank you.